The presentation is about kademlia, a peer-to-peer information system based on the isometric presented by Sai Dikshit Tadsetti. In this slide, let us know about the use of kademlia. It offers a number of features that other DSDs do not. Let us know what all it supports. Minimize data exchange between nodes and configuration information for nodes in the network, neighboring nodes, etc. are automatically spread to the kademlia network. Nodes in the kademlia network are identified through other nodes. This feature allows you to navigate paths between nodes at a low cost. It provides parallel asynchronous queries to avoid timeouts on inoperative nodes, and you can also prevent denial of service attacks. In this slide, let us discuss about the terminologies about the words what I have used in the before slide. In the previous slide, I discussed about what all kademlia supports. In that, there is a point mentioned. It used to minimize data exchange between the nodes. Let us know what's meant by the node. A node is a computer participating in the kademlia DHT network. And let us know what is meant by the pair. Actually, DHT stores data in KV format. KV it means key and value format, which is the same in kademlia. Actually, this key is a unique key for finding a value in the kademlia network. And the value is the data actually stored in the DHT. So the key V format, in the sense key and value format, means the key is the unique key for finding a value in the kademlia network, and the value is the data actually stored. And the other terminology is lookup. Lookup is the process of finding the actual value for a given key in the kademlia network. And next we have data or content. It refers to the actual data stored in kademlia DHT in pair format. Pair in the sense KV, key and value format. This is all about terminology, and let's go to the next slide. In this slide, let us know the key points. kademlia uses a 160-bit key to identify the node and data. Each computer participating in the network has a 160-bit nodal key. As mentioned above, kademlia stores data in pairs, like in KV, key and value format. So it also identifies data using a 160-bit key. And coming to the important protocols, the kademlia has 4 messages. They are ping, store, find node and find value. Let us discuss about these 4 messages. Ping, it means check if the node is working or not. It will check whether the node is in the working condition or not. And coming to the next message, it is store. Stores key and value data on one node. And coming to the third message, it's find node. It returns the k nodes located closest to the requested key. And the fourth message of kademlia is find value. It plays the same role as find node, but if there is data corresponding to the requested key, it returns that data. The RPC message returned to the request contains a random value specified by the sender. This random set value is used to match the requested message with the response result. In this slide, let us know what is a peer-to-peer network. A peer-to-peer network, in a short form, it can be called as P2P network. P2P computing is the sharing of computer resources and services by direct exchange between the system. Actually, these peers are equally privileged. And coming to the resources of the P2P network, the resources we have here is the processing power, disk storage or network bandwidth. A distributed system architecture, no centralized control, typically many nodes but unreliable and heterogeneous. Nodes are symmetric in function. Take advantage of distributed shared resources like bandwidth, CPU, storage on peer nodes, and fault tolerant, self-organizing. It also operates in dynamic environment, frequent join and leave in the norm. Going to the next slide. In this slide, we will discuss about the P2P systems. In this slide, we will discuss like what types we have and what all categories we have. Coming to the types, we have two types of P2P systems. They are pure P2P and hybrid P2P. Coming to the pure P2P system, a P2P system that has no central service of any kind. And coming to the hybrid P2P system, it's a P2P system which depends partially on central servers or allocates selected functions to a subset of dedicated peers. And coming to the categories of the P2P system, here we have two categories, the unstructured and structured. Let us know about unstructured P2P system. It will be no restriction on overlay structures and data placements. They are like Napster, Nutella, Casa, Freenet, BitTorrent. And coming to the second category, that is a structured category, it's distributed hash tables and place restrictions on overlay structure and data placement like COD, Pastry, Tapestry, CAN. In this slide, let us know about the distributed hash table. Distributed hash table. A dispersed hash table could be a course of a decentralized, disseminated framework that gives a lookup benefit comparable to a hash table. Sets are put away in a DHT. Distributed hash table in a short form can be called as a DHT, and any taking part hub can proficiently recover the esteem related with a given key. And coming to the responsibility for keeping up the mapping from keys to values is dispersed among the hubs in such a way that a alter within the set of members causes a negligible sum of disruption. This permits a DHT to scale to amazingly huge numbers of hubs and to handle ceaseless hub entries, takeoffs, and failures. Distribute information over an expansive P2P network. Quickly discover any given item can moreover disperse obligation for information storage. What's put away is key or value page. The key esteem controls which nodes stores the value. Each hub is capable for a few segment of the space basic operations store like key or value, and value is the retrieve key. And coming to the routing table, so the description what is given below is a simplified key is used. Kademlia routing table contains a list of each bit of each node ID. Every item in the list stores important information about the location of other nodes. Each item in the list generally stores the IP address, port, and node ID of the other node. The n-1th bit of the candidate ID must match the node ID. All lists corresponding to the distance of a specific node. The node that can go to the nth list must have the nth bit of node ID different. In a network with a 128-bit ID, different nodes are identified by 128 different distances. When a node joins the network, it is added to the list. This process helps other nodes to find the key. And let us know about the distance calculation. Kademlia finds the distance between points within the key spaces. XOR is symmetric, allowing users of this network to receive and perform routing requests precisely thanks to its routing tables. These allow other systems like COD to get information useful about routing thanks to requests. This metric consists of performing the XOR logical operation with the identifiers of each node. That is, if x and y are the identifiers of two nodes, then d of x comma y is equal to x plus at the rate symbol y. Given a distance delta and an identifier x, there is another identifier such that d of x comma y is equal to delta. This property ensures that such requests for an identifier they converge on the same route regardless of the origin mode. And let us know about the routing tables. The nodes in kademlia store the information of other nodes on object designated as buckets of a limited space of k nodes which designates its capacity. There is a bucket of capacity k for each 0 less than or equal to I less than or equal to 160. Therefore, there are 160 different buckets of capacity k. The usual capacity is usually k is equal to 20. Therefore, the bucket with index I contains the identifier of the nodes whose distance is between 2 I less than or equal to d, that is node 1 and node n, less than or equal to 2 of I plus 1. These buckets allow to cover the space of 160 bit keys possible. The nodes with short distances are classified in the buckets of lower index. Their organization is based on the information they have about the network distance between the other nodes and it. This information stored in the buckets, the nodes are able to create eternal binary trees for routing functions. And let us know about locating nodes. Node discovery is synchronous. Simultaneous search requests are donated by alpha, and the typical value of alpha is 3. Node sends find node request to alpha nodes closest to the desired key value. Nodes that have received Find nodes search their k buckets and return the k nodes closest to the key value. The request of search stores the results of the request and the k nearest node IDs. After that, the search requester selects the node stored node IDs so that each node requests the above. These actions are repeated. Each node knows best about the nodes around it. So the more these operations are repeated, the closer the key value is found. The search operation is repeated until there are no nodes closer to the key than the previous search result. When the search is stopped, the stored key nodes become the node closest to the desired key. Coming to the BitTorrent. The BitTorrent protocol, like many other P2P protocols, like ED2K, it is based on an implementation of kademlia to create a large-scale term distribution network. On the advantage that it represents compared to other protocols is that it works over HTTP, so that when several nodes download the same content concurrently at the same time, the content is distributed among them. Probably that the file can be downloaded simultaneously between a large number of nodes with minimal load increase. Coming to the importance of kademlia, it's a system that works by implementing DH2 over P2P. It works as a communication protocols for decentralized network and structured in P2P. The nodes contain a unique identifier 160-bit long generated from a hash function with the node's IP address. Being one of the most popular systems today, it emerged as a system that offered a number of features that other systems contemporaries did not contemplate at the time. In order to avoid saturating the network, kademlia has an adaptive system that minimizes the number of signaling and configuration messages that the system needs based on to the number of connected nodes. Coming to the ECS, if a hub needs to share a record, it forms the substance of the record, calculating from it a number that will distinguish this record inside the file sharing network hashes, and the hub IDs must be of the same length. It at that point looks for a few hubs whose ID is near to the hash. A looking client will utilize kademlia to look the organized for the hub whose ID has the littlest remove to the record hash. At that point, we'll recover the sources list that put away in that hub. It's used in many cases such as P2P, botnet, file system, P2P messaging, and kademlia is utilized in record sharing networks. Coming to the implementation, in the application to share files in P2P networks, BitTorrent has its focus on optimizing the propagation of content. This makes it very attractive compared to its competitors. To avoid the use of resources centralized when transferring files, BitTorrent uses distributed hash tables based on kademlia that allow you to find resources of content knowing the hash of your metadata. On the other hand, the Emular network also provides file transfer over P2P networks using a protocol transfer file known as eDonkey 2000. It's known as edo2k, based on priority queues, owns a solid kademlia implementation called CAT. This implementation provides a double service index with which it not only indexes resources, it is also used to index and search content based on keys. Our work studies the possibility of implementing a hybrid client compatible with both P2P network, which can exploit the advantages of CAD's indexing along with BitTorrent's content propagation speed. For this, we develop a prototype which supports content indexing using CAD, transferring using BitTorrent, and is backward compatible with clients currently implementing these technologies. Using this prototype, we measure times and speeds of content propagation in clusters of mixed nodes to conclude that development is feasible and widely benefits users. And at last, we'll know the disadvantage what are we having using kademlia. It has a few drawbacks as well. For instance, flooding the organizer. It's vital to send numerous more lookup messages to discover the proper collector. In contrast, pastry sends as it were single message which is coordinated to the receiver. And coming to the second one, looks up all little messages, and kademlia does not need to send numerous control messages for routing table upgrades, whereas kademlia may search the network with lookups. It does not search the organized with control messages in any case. These together may create more data activity. These are the references what I used to collect the data. Thank you.